Tai ką, labas rytas, kolegos. Kaip ir laikas pradėti, gal intervaliuojame, visi gražiai susirinkom. Tai pradedu lietuviškai, žodžiu, bet paskui perėsim į anglų kalbą, nes pranešimai bus anglų kalba, nes mes turim svečių savo partnerius projektų iš Lenkijos. Tai yra kovinės komanda, bet ten gali įsitaisyti žmonės, galit pažiūrėti, ar ne? Ir Krokovos komanda, galit paploti. Ir dabar pirmiausia norim paklausti, ar nuotoliu prisijungę žmonės mus girdi ir mato. Gal kas galėtų patvirtinti, ar garsas geras, ar girdisi, ar matosi. Nes mūsų šitas seminaras vyks mišriu būdu, tiek mes čia gyvai susirinkę, po visų pandemijų malonu visus matyti. Ir paskui prisijungia nuotoliu žmonės.
Judinskas parodė,
taip,
reiškia, turbūt viskas yra gerai.
So, good morning to everyone, once more. Let's start maybe our seminar in English as it was promised in the program. So, my name is Judas, I'm representing Asia Heritage Fund in Vilnius, Lithuania, and my colleague Vaidotas Valskys, also from the same institution. We will try to help you follow the seminar and maybe a little bit to manage our presentations and so on, questions, answers, and so on. So, small introduction. Maybe some of you have participated 2 years ago. It was in 2020, I guess. It was August. We gathered in Anykščiai, very nice city in Lithuania, you know. And it was our first demonstration seminar. We have demonstrated our so-called prototype, small machinery, because it's the code of the machinery is ISS. It means Algae Service Small Machinery. And this machinery, the goal of production of this machinery is collection of macroalgae. And I will introduce our partners of the project, joint stock company Baltic Environment, and Loretta and Jokubas are participating here. So they are the main institution who is dealing with the production of those harvesters, as we call them. In the last year, during the last year, we, all the partners, we went with this machinery together to the Poland, to the Krakow, and then the team hosted us here. And we demonstrated this machinery in Poland. Also, stakeholders from Polish institutions, they have participated in that seminar as well. And now is the third step. We are here, and in the afternoon, we will go to the Kaunas Reservoir, to Kaunas, and you will see our new machinery. It's so-called large machinery. The aim of that machinery produced for the collection of Cyanobacteria. Small one for Macrology, and this for Microalgae or Cyanobacteria. Yeah, correct? I told so. And of course, before the demonstration in the field, I mean that you should get some context about the project, about all other activities that we are dealing with within the project. Everyone, you have the program, so I will not repeat. You know the title of the project, you know the title of the seminar. And I guess that we should start immediately because time is running. And it was written in the program that we will have welcoming from Professor Judas Majidis from Brussels, that you know that sometimes connection with the strong capital of Europe is not so easy to reach. So a little bit we have small delay. And after that, I guess you can see that Judas Majidis on the screen, but a little bit later. So I guess that now we should start, and I would like to invite our main person in the project, our project manager, Dr. Judita Pareivienė from Nature Research Center, and Judita will introduce about all the project activities, about our future, current status, and so on, I guess. Yes? Judita,
good morning to everyone. It is nice to welcome all of you here, participate in our seminar. And I hope that today will be a lot of interesting information for you. And please don't hesitate to ask if you have some questions. So I wish you a pleasant time today. And I will start my presentation with the question: what do we want to achieve with our project, Algae Service for Life? It is natural questions because I got these questions very often. what are we? So it is big team that we implement this project. So coordinating beneficial nature research center, we have partners from Baltic Environment and Spilla business companies join us to the project, also non-governmental organization, Nature Heritage Fund, and two partners from the Poland. So they were introduced nicely by Zenona, so I will not repeat. So the question, what we want to achieve with our project? So firstly, we want to test and demonstrate the solutions, how to mitigate eutrophication. Eutrophication starts to be a very actual problem everywhere in inland waters, and not in inland waters, also in the sea. And if you see, okay, sorry.
Okay.
Okay. So you see how the human activity is huge and how it is affecting our water bodies. So not only the lakes that are Atlantic ecosystems, but also this also connected by the rivers to the sea. So why the problem is in the Baltic Sea? Because of inland propagation of anthropogenic pressure. So what is the main reason? The main reason is nutrients. The first who uptakes the nutrients, there's algae and cyanobacteria, because they are fast developing and those organisms, they uptake very fast and build a large amounts of biomass. What is the result? The result is algal blooms and bacterial blooms. And we see this also in the Baltic Sea. Here is the images from the satellite, and you see how blooms Nodularis fumigena in the Baltic Sea. We also have one more problem related with the eutrophication, because this biomass generates a lot of organic material. This organic material they say, and this way it depletes oxygen in the Baltic Sea. So what is the reason? The reason is huge dead zones in the Baltic Sea, and it's enlarging with every year. So what we want to demonstrate, so first we do some, we have suggested in our project different measures to first identify the affected ecosystems by mapping the algal blooms. So we made the interactive map where everyone from the society, from not only the scientists, but from society also, or from institutions can mark the places where the bloomings occur. And we will have information about date, about time. So it will be some more presented later. So we apply distant methods. So unmanned aerial vehicles and satellite images to have in imagination how the blooms are extend in our ecosystems, how the macroalgae blooms are, what the biomass is, and to answer what are the cyanobacteria blooms as well. So the next our proposed measure was to manufacture specialized prototypes to collect cyanobacteria and macroalgae biomass in the wild. It helps to restore water bodies. If it could be removed, so the ecosystem restores itself. So we want to help the ecosystem to restore. And also removing the toxic biomass, it also helps to protect people, to protect animals because of toxicity of this biomass. So another good point that those nutrients do not enter the Baltic Sea. So there are many tasks of harvesting biomass because it also contains both nitrogen and phosphorus. So removing both of nutrients, it's very important because it's really a good point for the ecosystem further functioning. So harvesting, we want to show in small ecosystems and in large ecosystems. Of course, in small ecosystems, if apply our measure, it can work and have a good results. We can clean and it will be viable. But for the large ecosystems like Kaunas Reservoirs, it's a little complicated because it's much more bigger measures necessary for that activity. It should be applied on the catchment. So what we are doing with our machines, so we are searching for hotspots. So we are searching for hotspots and we are trying to eliminate this biomass in the hotspots, in the scums and in the macroalgae agglomeration. So our project is dealing and target is environmental benefits first. So we have biomass collected already. What to do with this biomass? Is it waste or is it the resource? In our opinion, it's the resource. And we really want to use this biomass for the humans useful products, for people useful products. Algae biomass can be applied very broadly for low value products and for high value products. So it is energy, agriculture, ecological service, also cosmetic industry, pharmacy, biomaterials, food industry. So it's a very broad field of investigation. But we have wild biomass. You see this collected biomass here, macroalgae. It's a lot of harvested in Shatoy River. And here you can see how it looks like cyanobacteria collected in the water bodies. So this biomass has limited applications. We are trying to find where it could be applied. Why it's limited? Because it's very changeable. Ecosystem is changing, species changing. So every time we collect the biomass, it's different. So it's not easy to find the products, one product, and to commercialize this. So what we are trying to do in our project, we are testing for our low value products for biogas production and for agriculture purposes. And also testing for high value products. So we extract phycosamine. You can see some samples during our meeting. And also we use extracts of macroalgae for the cosmetics. So what the targets of our products, so it is valuable bioproducts. So if we put together, so it goes into circle, like we taking what is bad in the ecosystem, we are doing the goods for the humans. So it's like a circular economy. This is like a circular economy project. So, but we have to evaluate: is this profitable? Is it costs are suited are lower of these actions proposed compared to the costs that those activities needs. So we will do at the end of the project life cycle assessment analysis, and this will answer us how useful these activities proposed. So here is more information you can see on our website, and please ask questions. Here's our emails, and really I like to thank you very much for your attention, and I wish you all nice seminar and good, interesting information to everyone. Thank you very much.
So maybe there are questions from the participants connected online. Yes, raised hands, so maybe there are questions.
Yeah, from the auditorium, maybe someone would like to ask, or you did explain everything very clearly, everything is okay, and no questions. We will have all the dates today, so you can contact Vita during the break, so during the actual and to discuss all issues as well.
Also,
Thank you.
participants from the online can ask in the questions and answers sessions if there is a problem with the microphone or something, technical issues.
Studentai buvo?
Huh?
Studentai buvo?
Buvo.
Labai gerai. Šiandien. So, let's go. Aha. So now we would like to show you.
Vandens telkinių eutrofikacija arba ekosistemų praturtinimas organinėmis ir maisto medžiagomis yra viena aktualiausių aplinkosaugos problemų. Cheminių trąšų naudojimas žemės ūkyje, nepakankamai išvalytos nuotekos, buityje naudojami cheminiai preparatai didina azoto ir fosforo junginių prietaką į vandens telkinius. Tai skatina nekontroliuojamą makrodumblių ir melsvabakterių augimą. Perteklinė dumblių masė ir toksiškos santalkos mažina biologinę įvairovę, sukelia kitas aplinkos ir socialinės problemas. Siekiant sumažinti perteklinę dumblių biomasę kaip fosforo, azoto ir cianotoksinų šaltinį, Mokslinių tyrimų institutas Gamtos tyrimų centras kartu su kitomis Lietuvos ir Lenkijos institucijomis verslo įmonėmis inicijavo LIFE programos projektą Dumbliai ekonomiškai pagrįstų vandens ekosistemų paslaugų dalis.
Pati Algae Service projekto idėja kilo iš daugiamečių mūsų tyrimų, kada mes pastebėjome, kad azoto ir fosforo kiekiai didėjantis mūsų vandens telkiniuose iššaukia tokį nepageidaujamą reiškinį kaip vandens žydėjimai.
Projektas įgyvendinamas Lietuvos ir Lenkijos eutrofikuotuose vandens telkiniuose, kuriuose makrodumbliai ir melsvabakterijas intensyviai vystosi ir formuoja santalkas Liepos-Rugsėjo mėnesiais. Dideli makrodumblių biomasės kiekiai nustatyti Nevėžio, Jūros, Dubysos upėse, Opružinskėje ežere, Kauno mariose ir Simno ežere melsvabakterių santalkose aptiktos toksinų koncentracijos kėlė grėsmę žmogaus sveikatai ir gyviems organizmams. Maistinių medžiagų eliminavimas iš ekosistemos, surinkant dumblių biomasę, leis gerinti ne tik vidaus vandens telkinių, bet ir Baltijos jūros būklę. Dumblių santalkoms nustatyti ir vertinti kuriama nauja, tradiciniais algologiniais ir nuotoliniais tyrimų metodais paremta metodika, kuri leis greitai identifikuoti santalkas, nustatyti geriausią dumblių biomasės surinkimo laikotarpį. Bepiločiai orlaiviai projekte naudojami biomasės santalkų stebėsenai mažuose vandens telkiniuose ir upėse.
Tam, kad apžiūrėti visą Simno ežerą, mums reikia pasidaryti skrydžių planą, reikia tik tai įsikelti iš savo istorijos skraidymų. Tokiu būdu mes iš karto gaunam visą skrydžio trajektoriją, turim skrydžio aukščius, priklausomai kokią kamerą norim fotografuoti ir visą tą informaciją rašom į lėktuvą. Tokiu būdu mes turim labai tikslės pozicijas, kur ir nuotraukos daromas ir galim labai greitai surasti vietą, kur tai buvo daryta ir kiek toj vietoj daugiau ar mažiau yra dumblių.
Palydovinės nuotraukos naudojamos nustatyti dumblių santalkas didelėse vandens ekosistemose, kaip Kauno ar Kuršių marios. Projekto metu kuriami specializuoti dumblių biomasės surinkimo prototipai.
Projekto metu inžinierių komanda sukūrė du inovatyvius prototipus. Šių prototipų technologijos yra užpatentuotos. ASS prototipas tai yra transformeris, kuris skirtas rinkti mikro ir makro dumblius mažesniuose vandens telkinuose. Šiai dienai turime didelį susidomėjimą iš potencialių klientų dėl šių prototipų ir tikimės, kad artimiausiu metu šie įrenginiai bus komercializuoti.
Prototipas ASS yra draugiškas aplinkai, sumontuoti elektriniai varikliai, akumuliatoriai ir saulės baterijos.
Kūrėm makrodumblių surinkimo įrenginį, bandėm pradžiai presą, bet presas nepasiteisino, tai teko panaudoti preso principą ruloninio. Visa žaliava pasiduoda iš priekio konvejeriais, juos nuskina piršteliai tokį savaime, kurie sulenda į transporterį, kadangi nesiviniotų. Makrodumbliai labai turi gerą savybę viniotis į rulonus.
Keičiama prototipo priekinė konstrukcijos dalis gali atlikti dvi skirtingas funkcijas – rinkti makrodumblių biomasę arba melsvabakterių santalkas. Projekto metu testuojamos galimybės biomasę panaudoti biokuro organinių trąšų gamybai. Iš biomasės išskiriami vertingi cheminiai junginiai, kurie gali būti naudojami įvairiose pramonės srityse. Biomasės poveikis miežių, kukurūzų, bulvių auginimui ir derliui testuotas eksperimentiniuose laukeliuose.
Matome eksperimentinius laukelius, kuriuose yra uždėta skirtinga biomasė, makrodumblių, taip pat yra su trąšom, be trąšų. Viena biomasė yra įterpta pavasarį, kita rudenį. Priklausomai nuo to, kokia buvo biomasė, labai dideli yra skirtumai tarp laukelių.
Pirminiai testavimai parodė, kad dumblių biomasės įterpimas į dirvožemį skatino miežių augimą, didino derlingumą ir atskleidė perspektyvias galimybės dumblių biomasę naudoti kaip natūralią trąšą. Taip pat testuojamas biodujų gamybos efektyvumas naudojant makrodumblių biomasę, keičiant substrato santykį ir sudėtį.
Tiekiami dumbliai, maišomi su mėšlu ir paskui maišomi su vandeniu. Priėmimo kameroje šitie visi trys substratai tarpusavyje yra sumaišomi, homogeninė masė yra dar papildomai pašildoma ir toliau jau tiekiama į patį pagrindinį bioreaktorių. Jame tas substratas pašildomas maždaug iki 38 laipsnių Celsijaus temperatūroje. Tokiu būdu metanogeninės bakterijos esančios fermentatoriuje skaido šį substratą ir išskiria biodujas.
Bioreaktoriuje iš 1 kubinio metro substrato vidutiniškai išgaunama 1 kubinis metras biodujų, o iš jų pagaminama apie 2 kW elektros energijos.
Bakterijų perteklinę biomasę galima panaudoti ir aukštos pridėtinės vertės produktams išskirti, tai būtent fikocianinui, tai yra natūralus dažas, kuris turi specifinę mėlyną spalvą. Pats procesas fikocianino išskyrimo yra gana sudėtingas, turi keletą etapų.
Fikocianinas pasižymi antioksidacinėmis, antibakterinėmis ir kitomis biologiškai vertingomis savybėmis. Priklausomai nuo išskirto natūralaus pigmento kokybės, jis gali būti naudojamas kosmetikoje, maisto pramonėje, maisto papildams ar medicinos diagnostikoje. Makrodumblių biomasėje aptikti ir išskirti unikaliomis savybėmis pasižymintys įvairūs biologiškai aktyvūs cheminiai junginiai. Junginiai išsiskyrė odos elastingumą didinančiomis, antioksidacinėmis ir drėkinančiomis savybėmis, kurios atveria galimybės dumblius naudoti kaip naują žaliavą emulsijų, drėkinamųjų, maitinamųjų, senėjimą stabdančių kremų ir kitų kosmetikos priemonių gamybai.
Viena iš projekto Algae Service for Life veiklų yra ne tik suinteresuotųjų institucijų atstovų, bet ir visuomenės informavimas ir įtraukimas į veiklas. Sukūrėme internetinę programėlę, kuri yra skirta pažymėti žydinčius vandens telkinius ir tokiu būdu įtraukti kiekvieną gyventoją, kuris gali pateikti informaciją apie žydintį vandens telkinį.
Interaktyviame žemėlapyje galite pažiūrėti informaciją apie pažymėtus žydinčius vandens telkinius. Taip pat sukurtas klausimynas vandens žydėjimai, visuomenės suvokimo ir žinių apie vandens žydėjimą tyrimui atlikti. Eutrofikacijos problemos sprendimui projekte naudojamos inovatyvios technologijos skirtos identifikuoti, rentabiliai surinkti dumblių biomasę ir kaip atsinaujinantį gamtos išteklių tvariai panaudoti kuriant vertingus produktus. Tokiu būdu gerąją ekologinių paslaugų praktiką siekiama derinti su žiedinės ekonomikos principais.
Our team in Krakow, our project team in This video was about the first years of our activities. Till now, we can say, because it was produced last year. And you can find on YouTube this video if you'd like to show to your colleagues. And also, I remember during the video that in the folders you have our questionnaire. So please, all the guests, all the participants of the seminar, when you will have time, please fulfill this questionnaire and leave on the table. Or you can do that on our internet page or website of our program as well. So, and tell to your colleagues also to fill this questionnaire as possible. So, thanks a lot. And now we are moving to our next presentation, and I'd like to invite Professor Wozniak from Krakow, LA's Director of Institute of Nature Conservation and our project partner in Krakow. So, please,
hello, everybody. I have only 15 minutes, so of course it's not possible to say everything about cyanobacteria during this 15 minutes. But I try to say you a little bit. They are very small creatures, so I try also to say a little bit about them, and also present what we have done up to now. My team and I, we are responsible for cyanobacteria part. We love cyanobacteria, we like them, they are really very beautiful. So this is the reason why we focus on this group of algae. What is the cyanobacterial bloom? This is the first question. This is very important because even if we know that this phenomena exist all around the world, there is no one definition. So just to be sure what we are talking about, I would like to specify what I'm thinking of, what is cyanobacterial bloom, and this is very short and not complicated definition. So this is a dense population of cyanobacteria that discolor the water, and of course there are a lot of species of cyanobacteria. But some of them are, I wouldn't say specialized, but okay, so for this moment, just go this way, that they specialize to do in creating bloom. So there are some species which quite often create bloom. So they are Aphanizomenon. You can see here is Aphanizomenon, and also Microcystis. This species is all around the world very often, and also Nodularia, which is in Baltic Sea, and Planktotrix or Trichodesmium. This problem is not only local one. This is not only problem for Baltic Sea. This is not only problem for Kaunas Reservoir or for some reservoirs in Poland, but this problem is a global environmental problem. This problem is about the water. We know that we have more and more problems with getting good water because of drought, because of pollution, and also because of the cyanobacterial growth. So if we want to have water and good quality of water and to have a good services in ecosystems, so we need to do something. Okay, so and we need to, this is very important thing, just to go in emergency and to help our water. So what is the main problem with cyanobacterial blooms? The most important factors responsible for the frequency and duration of cyanobacterial blooms. So there are the two main problems. So this is anthropopressure and climate change. And the anthropopressure, so of course we did talk a little bit about this. So this is pollution. This is influx of nitrogen and phosphorus, and this is also artificial transformation of rivers, building reservoirs, and everything what we can do and what we do for water. And there's also plus climate change. We know we can see this problem. So this is not only rising or increased temperature. Okay, so increasing temperature is very important because cyanobacteria are a group which like high temperature, but this is also a problem because of changes in stratification of waters and changes in also in biochemical cycles in the waters and also with light penetration. So going together, anthropopressure and climate change, they are responsible for more frequent and for more violent cyanobacterial blooms. And of course, this is also another topic. This is only like touching this problem. Also, Dita talked about this. But what is the problem? So, like environmental problem with cyanobacterial blooms. This is not only because of bad color of water, not only because of bad smell, but this is also because of some more problems which are going, in the environment. And this is, first of all, this is like increasing of sedimentary detritus. And next, there is a problem with oxygen, and it might be oxygen depletion in the decomposition of organic matter. And what is next is the formation of oxygen deficit and release from the bottom sediments into the water other compounds, which might be also very dangerous for organisms. Next is decrease of water transparency, because when we have very dense bloom, it's cover the whole surface, and there is a problem of going light into the deeper part. So then also is decreasing condition for any other organisms, and also deterioration of conditions of fish and benthic fauna, which is also very important for waters. And the last but not least, of course, so this is release of toxic compounds, which might be poisoning for fish, shellfish, also and other organisms, and also they can do problems for people who live because of touristic industry and because of any other like food production industry, because when it's a big releasing of toxic, we can't use fish, we can't use shellfish, we shouldn't bath. So during this time and also a few weeks later, the waters should be closed. So this is might be very big problem. And so like economies exist all around the world. So there is also some accounting and also some information. What is an economic cost of blooms? And of course, this is an increased cost of drinking water. So maybe this is not very important for Lithuania, because I know that you use drinking water from underground sources. But in Poland, we use a lot of surface water as a drinking water. So this is very important. It reduced value of aquatic water bodies used for commercial uses, as I said. Also reduces value of aquatic water bodies used for recreation. It also net economic losses for tourist industry, also mentioned before. Net economic issues for aquaculture, health cost to humans, and also health cost to livestock and pests, and negative effects on aquatic ecosystems, like changes in biodiversity and also in functional diversity, reduced value of nearshore houses. And this is not all. We can do a long list of problems. And what is very nice, so there is also some calculation. What is the cost for human illness if cyanobacterial blooms exist? What to do? We can go in several parallel ways. So first of all, we can clean and protect of catchments of the waters. We can also apply of principles of sustainable agriculture. We can restore of lakes and reservoirs. Educate society, this is very important thing. Keep away from polluting, punish of polluters, which is not nice. Okay, so this is not good just to say you are bad, so you need to be punished, etc. But sometimes we need to do this. And this is not all. Okay, so what we can do next, this is what we do. It is like also Judas said, circular economy, so just taking this biomass, and use it as a reuser biomass and to do some any other product. So like Judas said, this is called a circular economy. So now what we have done up to now, I mean our team from Krakow. So we have chosen 4 different places. They are small, rather small waters. So one is an oxbow lake, 2 some ponds which are used as water, drinking water for Krakow agglomeration, part of drinking water. Here you can see these two ponds from above, and also 1 artificial lake in Silesia region. All of them, so we found in all of them Cyanobacteria. Of course, sometimes they are bigger, sometimes they are smaller, so we can't predict, what happened with them for the next year, because it's also connected to weather conditions. So we do monitoring. So we do monitoring from the beginning, just to know condition of this water, just to know what happens during this year. So it will be 4 or 5 years. It's quite good period for monitoring and just to know what happened during these years, and also what will happen after our project. We testing biomass quality. What means that we measure carbon, nitrogen, and phosphorus in biomass of cyanobacteria, which is collected from these reservoirs. And here you can see all of 4 reservoirs, like they are this pond. Here is this lake, the biggest lake in Silesia region, and this oxbow lake. So as you can see, using chlorophyll as an indicator, so this oxbow lake is the most productive. But measuring carbon in the biomass, we have a quite good results in biomass from these 2 ponds. What's next? This is a nitrogen. So here you can see a total nitrogen in the water, and here is a nitrogen in biomass. And again, so it's quite good amount in the biomass from this pond. And sorry, but for phosphorus, we didn't have enough samples. We still work on them. So I hope that during the end, I will have much better results. But again, here you can see that in this 4th place, where is a big amount of total phosphorus, we also have a big amount of this phosphorus in biomass. So collecting this biomass from the water, we can also collect phosphorus, nitrogen, and also toxins, and also carbon. Here is an example of toxins, which is like a almost I say pattern year after year. So the most promising months for collecting biomass, just to take some toxins, is August or September. There are 2 months with the biggest cyanobacterial blooms in those reservoirs. What next? We also develop an UAV method of monitoring of cyanobacterial blooms in freshwater ecosystems. So this is very important if we want to look for water bodies which we don't know. Okay, so this is for big areas like Baltic Sea. This is very good solution just to use satellites, but for small water bodies, this is not always possible. So we developed this method together with Łukasiewicz Institute of Aviation in Warsaw. So last year we started to develop of remote sensing index. We used 30 styrofoam frames putting into the water. We left them for 12 or 24 hours a day. For 24 hours, just to not disturb the surface. And later we measure chlorophyll A and phycocyanin, which is very good indicator for cyanobacteria, in this foams frames, and also after that collected and dense material, just to compare which measurement is better for indicators. And here you can see our oxbow lake and also these frames which are putting in this part, which is the most dense for cyanobacterial blooms. And what we get, so we get that for chlorophyll A correlation for measurement in situ is 75%, which is very good. But for dense samples, it's a little bit more than 50%. And also for phycocyanin, we used very good correlation for these samples which were measured directly in the water. So it means that we can develop this indicator, like using photos not from satellite but from above the water, and also using and later analyze these photos. What is it's time for me? And later analyze, just not going around this these reservoirs, but helping with. But this might help us to find new places for collecting biomass. And this year we also collected during the summer, thanks to this harvester, small harvester, we collected from 2 reservoirs 2 different types of biomass. This one is with this is a bloom of Macrocystis, and this is a bloom created by Aphanizomenum acre. And this one we want to test it also as a biogas. So we also started collaboration with another team in Poznań who work with biogas, and so you can see this this part is developed quite good. So we hope to have some nice results. And any other activities? So this is like raising awareness and dissemination of our results. So we present our results during different meetings and also conferences, and also releasing some like press release and also some papers, and also working with this map, just putting where we can find cyanobacterial blooms. This is also our finding this year in Germany, so we try to look in other places where we are. And also, as I said, so we present our results during the conferences, national and international. And that's all. Thank you very much.
No, thanks, Stella, for your presentation and for your team. Edward and Martina also are presented here, not all team. Yeah. So, but anyway, so do you have what maybe from both sides, some questions? No?
I can't see any raised hand, but maybe you have some questions.
And
Still no.
Yes, Mindaugas. I got that. Yeah.
No.
Mindaugas,
I have a question about toxicity. You mentioned that the study is not done like this, and if to apply these materials for example, if apply these materials for as fertilization product and so on, one thing is it some kind of regulation for these toxic materials, and can these products meet, or and if there is a risk, for example, if we fertilize food crops with these materials, how you see that?
We do, as far, we do not experiment with fertilizers using cyanobacteria biomass. This is what is done. It is done by the second team, and this is with macroalgae, which not toxic, not toxic. And however, I have read some papers, scientific papers, and I also found that in these papers that this is not necessarily a big problem. This is all what I can say up to now. Maybe
Can I add, because there is a regulation, European regulation, that we cannot apply the cyanobacterial biomass for agriculture. But we can apply, for example, for forestry or for biomass plantations. So if possible, because it's not suitable for the food as a food. So, actually, we are working on this question because we are trying to modify this biomass to make it not to be non-toxic. So we are working on these questions. So changing the biomass.
Okay, thanks. Thanks, Judita. So we have this.
Actually, my question was similar to colleague, but I was intended to ask about heavy metals. Have you measured concentrations of heavy metals?
Me not, but you have the sorry.
We measured the heavy metals in cyanobacterial biomass and in macroalgae biomass. So there is lower the limit allowed by the regulations. Yes.
Okay, more questions? No. Yes. Okay, thank you so much. At the beginning of the story, I forgot to say you that all the presentations will be uploaded to our website of the projects, and after the seminar, you can download all the presentations. They will be available. Also, we are doing the record of the seminar, so all registered participants, we will send the link to the record of the seminar or the materials, so you will find also. We will send a letter after that. So the first part is over. Thanks for all participants, and I guess that it's very, very good time for coffee. So all the participants that are in remote mode, so also please make your coffee at home or in the office, and we are going outside the seminar. The coffee service is here. So we are returning back sharply quarter to 11. Quarter to 11, we are starting next presentation. Thank you.
Taip, dar dabar tik jūsų kolegija, aš dar žiūrėjau, nepykit, kad aš jūsų pastatą. Reikia nusiųsti nuorodą, bet aš kai metu, kai atvažiuoju, neveikia. Ar mes apie šitą mailą darėm, kad tai neatsinaujina, tai truputį. Gal galit tada jūs jai persiųsti? Gerai. Tai man tik tiesiog jūs prisijunkit prie Gmail. Gerai, jūs atsiprašau.
Čia
Jo, šitas pasiruošęs. Jo. Tai dėstykite pašto. Aš turiu pardownloadint visus prisijungimus duomenų. Dar gyventi truputėlį, vykite. Vat aš galvoju, kaip per kameras rodo, bet dabar čia mažino šitą downloadimą. Minučiuke.
O kam šitą čia?
Dima, neatrodo, kad tamsokai.
Nu, šiaip atrodo labai skylėta.
Bet ten tai tokia
A, ne, aš žiūriu aš per kamerą.
Add some crowdiness.
Yes. You want to be in this crowd.
Welcome. Kur pasižiūrėti, man nebent per telefoną pasijungti.
Čia su to... Jo, šito vidos reikės. Šitą rodysim ir...
Šitą rodysim.
Šitą jau kalbėti apie mašyną naują technologiją kalbėti. Mašinė, kur aš atsiprašau.
Aš siūlau ir tą parodyti. Tai šortą.
Šitas?
Šitą parodyti siūlau irgi, nes maža kaina nebus būtų, ką tai ir koncentracija.
So, ar jau jungtas?
Paruoštas.
Ar jungtas?
Mikrofonas įjungtas.
So we'll continue after the coffee break. So nice that all of you return back. So, and you remember that I told that it's very difficult to read Brussels sometimes, but today we have succeeded. And now we have a welcoming speech of Professor Judas Majidis, who everyone knows that he's a member of Euro Parliament from Lithuania and working in Committee of Environment, Public Health and Food Safety. It means that the topics of that committee is very close to our project, very related. So in Judita contact with Professor Macrology, they have discussed about all these issues regarding our project. And now, please, we are going to the Brussels.
Dear participants and organizers, I would like to express my sincere appreciation for all the hard work you are doing toward a better environment for all of us. I'm glad to see specific actions in the field of public health, environmental protection, and food safety are being transformed into life. It's exciting to see possible solutions to our shared challenges becoming real actions. I believe that efforts on Algae Service for Life, main activities as a collection of algae in water bodies, processing of algae biomass into bioproducts, etc., sets a great example of where we should move forward. As a research worker, I'm always very happy to address the scientific community because I believe that science is the basis, the answer, and the future of everything. Unfortunately, I cannot attend this wonderful seminar in Kaunas in person today. I had to return to the new active political life in the European Parliament in Brussels. Thank you very much for the invitation, which was sincerely and very positively surprising and inspiring to me. In today's gathering, I would like to stress the importance of our European choice, the European Green Deal. Despite today's geopolitical and economic situation seeming to be frightening, we are at the crossroad with only one right solution, moving towards climate neutrality, preserving biodiversity, eliminating pollution, and all the other actions related to stopping climate change and securing the future for young generations undoubtedly will require enormous efforts from all sides. Different governments, various types and levels of institutions, businesses, and citizens will need to find a common way moving forward. Possibly, I could say no one could understand better than you that science and research will play an important role here in helping to shape a safer and more sustainable future. I believe we are already seeing such focus through various initiatives and instruments. LIFE program, which is no exception, today proudly counts its 30th anniversary, hopefully. With the LIFE financial instruments, we continuously will have more and more necessary future-oriented projects. My main responsibilities at the European Parliament are also related to the topic. Both you in your Algae Service for Life project and me are working towards the same goal, to reduce climate change and environmental pollution and to improve the quality of our lives. I was really very interested in the innovative perspective towards algae research, CO2 reduction, cyanobacteria, harvesting, sustainable farming, and public health protection. You are doing very important work in the fields of biodiversity and reduction of water pollution. Your emphasis on circular economy is also significant. As a member of the European Parliament, ENVI means Environmental, Public Health and Food Safety Committee, I have an opportunity to learn new each time how actions in one field can positively affect the situation in other areas. We see the same today with your work on algae and its harvesting. Looking through the circular economy approach, learning about new ways to harvest algae already enables the possibility to start considering new opportunities for using what was harvested. There is no secret that the circular economy plays an important role in shaping nowadays European environmental policy. So, collecting useless organisms and finding ways to put them to good use seems to be a very good example of circularity. Of course, I am very glad that this seminar will take place in my hometown, the city of Kaunas. It is very important, both to the city and Lithuania, that the main topic of the seminar is the Kaunas Reservoir, the largest artificial water body in Lithuania. An interesting fact, when I was born, the Kaunas Reservoir did not exist yet. I was the construction of the hydro power plant during my childhood. I hope that upcoming years will bring more attention to the Baltic Sea question from the European Commission side. More needs to be done both on the legislative side and on the side of creating incentives, for example, on creating innovations. I would be very interested to hear later about how successful the seminar was in Kaunas and to talk in the future about environmental issues that are important to the European Union. I would like to thank you once again for sharing your knowledge and working in such an interesting field. Also, to encourage you to continue your work because it may and will positively affect not only our citizens, but biodiversity and the environment in general. Quality of life will depend on research projects and innovations. Your innovative perspective on environmental protection and application of technologies in the research of nature are what Europe should rely on today and in the future in the fight against climate change. I wish you the best of luck and an exciting day today ahead. Thanks.
Indeed, it was great. We had not expected such nice speech of Professor Judas Majidis. As we told, this originally from Kaunas. I knows very well the situation in Kaunas Reservoir. So it's really, how to say, a man who knows these things. And I would like to thank you, Mr. Raymond Majidis. He is presenting here. He is the head of the office of Professor Judas Majidis in Lithuania. Yes. So it was big effort to find the professor, how to say, and to prepare this welcome speech for us. So I guess that during the final conference of our project, we will invite Professor to participate in our final conference as well. Okay, so also I'd like to mention that as far as I remember from the registration that some participants are from different countries, such like Bulgaria, like Poland, like Sweden. Also, I know that someone was from European Commission that was mentioned during the speech of Professor Judas Majidis. So also thanks for participation in this our seminar. So we continue our work. Time is running. And now I would like to invite Jūratė Kasparovičienė, Doctor of Science from Nature Research Center. And she will present about the situation in Kaunas Reservoir, what we have now, what are the problems in that reservoir. And also, co-authors of that presentation is Jūratė Karosienė. Where is Jūratė? I can see now. coming VP, and
Run away.
Majidis Research Center, and also Richardas Korupskas from Vilnius University, and Antanas Gedvilas. He now is preparing the aerial vehicles for our demonstration in the afternoon, so you will meet him in the afternoon. So all four authors, our partners. So Jurate.
Thank you for the introduction. In my talk today, I will briefly present the information that was obtained by our team during the Kaunas Reservoir testing. At the beginning, I would like to introduce the Kaunas Reservoir. It was created in 1959 by damming the Nemunas River. More than 35 villages were flooded. The reservoir supports the operation of the Kaunas hydroelectric power plant, and in 1992, in order to protect the local environment and cultural heritage, Kauno Marios Regional Park was established. Kaunas Reservoir is the largest artificial aquatic ecosystem in Lithuania. It occupies more than 65 square kilometers. The reserve is relatively shallow, with average depth from 9 to 12 meters, a maximum more than 24 meters. In addition to the Nemunas, 43 other tributaries of different sizes flow into Kaunas Reserve. So the area of the basin is about 700 times larger than the water body itself. As a result, a lot of nutrients enter the reserve and promote eutrophication processes. The reserve located near the city of Kaunas, the second largest city in Lithuania, and people use recreational water for all manner of activities, including swimming, different water sports, boating, fishing, and outdoor education activities. Also, it is one of the most important sites in Lithuania for water birds hatching, feeding, and for migrating ones. Unfortunately, oh, no. Unfortunately, water quality at Kaunas Reservoir has been in decline for a number of years. The reservoir is experiencing extensive cyanobacteria growth, which has negatively affected the social, economic, and environmental values of the aquatic ecosystem. In high nutrient conditions, cyanobacteria can rapidly reach bloom conditions, often appearing as a bright green scum coating the water surface. These blooms lower the aesthetic value of the water and also can pose a threat to human and animal health. So water quality of the reserve is important for socially safe environment. The monitoring results obtained by Environmental Protection Agency show that ecological status of Kaunas Reservoir based on physicochemical and biological parameters is moderate or bad. Based on total phosphorus values, it is very bad. Phosphorus is an essential nutrient for to photosynthetic organisms' growth, and its extensive amount in the water can contribute to blooms. One of the biological parameters to monitor
water quality and to determine bloom intensity is the chlorophyll A amount. The results of 3-year studies showed high chlorophyll A amount at 2 sites in Kaunas Reservoir, Grabutiškės and Pažaislės. The concentration reached more than 1 milligram per liter in July, August, and indicated the intensive Cyanobacteria blooms, Cyanobacteria growth. The level of chlorophyll A can be used to estimate the general classification of water body or identify potential problems. Chlorophyll A concentration has been recommended by World Health Organization as an indicator to estimate cyanobacterial blooms and safe values for recreational water. If possible, chlorophyll A amount in recreational water should be lower than 24 micrograms per liter. This permits some balance between recreational use and potential nuisance issues. Since July, in most cases, the chlorophyll A amount exceeded up to the threshold value of alert level 2. Additionally, chlorophyll A concentration in 2 profiles was evaluated. The results showed that the amount of pigments significantly exceeded the threshold value for recreational waters in the most of investigated in this profile sites in 2020. And in the scums, the pigment concentration exceeded up to 1,500 times the threshold value of the alert level 2. Studies of chlorophyll A amount spatial distribution in the profile of 36 sites in 2021, vigilance level was developed only at 8 sites. At 7 sites in the picture, there are black dots, more than 100 times higher chlorophyll A values than the threshold values of alert 2 were fixed. Algae blooms come in many shapes and sizes. Several pictures of different water blooms based on cyanobacterial chlorophyll A concentrations and alert levels. Vigilance level, as we see in this picture, is usually invisible and the microscopic analysis is required. During the intensive blooms, cyanobacteria are unevenly distributed. They form dispersal, honeycombed and continuous areas, extremely dense accumulations. Mainly, Macrocystis, Aphanizomenon, and Dolichospermum species form blooms in Kaunas Reservoir. Composition and relative proportions of cyanobacteria species found in phytoplankton were similar. Also, prevailing species differed in several cases. Macrocystis prevailed almost in all bloom occasions. So, the blooms in the reserve are formed by toxic Macrocystis cyanobacteria that produce and accumulate large amounts of hepatotoxins, microcystins. Harmful effects of cyanobacteria can occur even when visible signs of a bloom are absent. Two groups of cyanobacteria produce toxins, hepatotoxins and neurotoxins, were detected in reservoir. Among detected toxins predominated the hepatotoxic microcystins, which can damage the liver and digestive system of the biota. Microcystin concentration often exceeded the guidance level 24 micrograms per liter proposed by World Health Organization for recreational waters. And during extensive blooms, the water and in cyanobacteria scums, the microcystins amount were more than 200 times higher than the threshold value for recreational waters, and posed a serious risk to the human and the biota. As we see, small amounts of neurotoxins, anotoxin A and saxitoxin, were detected. As a result, revealed cyanobacteria blooms in the Kaunas Reservoir are very heterogeneous in space and time and require frequent monitoring. Therefore, it is important to estimate cyanobacteria distribution and to observe a wide space in a short period. So, for identification of cyanobacteria distribution, we applied unmanned aerial vehicles that take orthophotos of analyzed areas. Then analysis is performed in two different stages. First is fragmentation of orthophotos for after analysis, and then follow classification of extracted areas. And 8 types of agglomeration has been distinguished based cyanobacteria density. In the analyzed profile by UAV, concentrated bloom and low density areas dominated, and each individually accounted nearly 50% of tested area. Their calculation showed that up to 19 tons of biomass could be accumulated in UAV evaluated area, which occupy about 1% of the total area of the reserve. So we can imagine what blooms happens in Kaunas Reservoir. And we think that our work and others, and we will have in the near future Kaunas Reservoir, as we see on the right side.
Our future, that's me.
Yes.
Yeah.
Thank you very much.
It's been nice. For the team and for your writer, for the presentation. We have some questions from outside auditorium.
Nope.
Čia klausimų. Yes, please. Palaukit mikrofoną, kad girdėtų. Ne. Galit išversti. Kas išvers?
Aš tik norėjau pasitikslinti duomenis monitoringo iš aplinkos apsaugos agentūros, ar jūsų būtent daryti.
Lentelė, kuri in slide number 6, where I show
Number 6?
number 6, I think. Yeah. Yes. In
This
slide
one?
number 6, the data from Environmental Protection Agency monitoring results, they are here in this table.
And in 2021, it was your results then?
Yes, yes,
Profiles,
yes.
yes?
Yeah, all
This is
profiles.
nations and this is-
Yeah.
Okay, more questions? No more questions. Thanks once more, right?
Thank you.
Okay, moving further, and as it was mentioned in the video, you know that it's very important to get feedback, to get the knowledge to the society, of course, and after that to get feedback from the society as well. How they are feeling, living close to Kaunas Reservoir, where we have quite complicated situation as we see. So my colleague, Dr. Majidis, is now shortly, briefly will tell what we are doing with the transferring knowledge to the society. Of course, all the partners giving the material to us, and after that we are uploading and so on and so on. Please, Majidis, tell about that.
About communication tools. Okay.
Communication tools, yes.
So my
That's
presentation will be short because my voice is not so strong today, so sorry for that. So the presentation is about Macroalgae blooms in water bodies, but thank you, Dima. But also we will talk about other communication tools which are designed and created not only, how to say, to inform, but involve the general public, the wider society, and so on. So first, what we can see, we have the application, which is designed to mark locations of blooming water bodies. I mean, we can mark in Lithuania, in Poland, doesn't matter. We can mark also in Germany, as Ella has done that. I have checked that, it's not a mistake, it's in Germany, that's perfect. Yeah, also a nice photo. This information, what is the purpose of this information? This information will be used for data analysis, of course, in the manner of the, how to say, spatial distribution, but also in the manner of the time. Because as we can see, who are participating live here, we have a roll-up and we have made it, I think, 1.5 years till the start of the project. And we have some few points, I can tell 20, 30, 40 or something like that. But as we can check, okay, I will show this, you can compare. Now we have hundreds of the marked blooming water bodies. But getting back to the exact RGS application, we can check it online now. I just have to bring the this is the exact application, which can be opened or reached via the quick response or QR code, or via our website, or if you find some of the notice boards near the Kaunas Reservoir and so on. Also, you can, how to say, take a photo of the QR code. It will direct you to the RGS application. And it is very simple and it is very quick to fill in. Some data are as time and data is filled in automatically. You can check it, of course, or change if there is some kind of a mistake, if there's a poor quality of the internet. Next, you have to, of course, agree to share your location. If you want to mark the blooming water body, you have to agree with the location. Next, you can attach, if you have your photo in your device's gallery, or you can directly take the photo instantly in this ArcGIS application. Also, you can mark, which is quite important for checking if it's a correct data, correct location, the type of the water body. Is it lake, river, sea, and maybe other type, like, I don't know, reservoir. It's not, yeah, it's not in the list. Reservoir or some kind of artificial water body. And of course, the name. The name is also very important to check if the location is correct, because if the name and location is correct, we can say that it is okay. What I have not mentioned, of course, it is very important to attach the photo. because then the experts can say, or how to say, evaluate if it is really a blooming or is just some kind of different issue with the water body. I don't know. Žiedadulkės užkrito, kaip angliškai. Spores. Paul. Sorry, Paul. Yeah. Okay, let's return to. Let's do like that. Okay, so this is the map. So all the gathered data through this RGS application instantly comes available via the interactive map. So we can also check this interactive map, how it looks like. It's a little bit difficult for me to navigate from the browser to the PowerPoint presentation, but I hope it will upload. Yeah. Now you can see the most up-to-date information. And of course, if you have marked some kind of water body, you have filled in the information, you can instantly check if your point is here. So maybe we can check, okay, Kaunas Reservoir, yeah? Yeah, there are some points. And of course, if you can mark, they provide, I can see if they provide the photo, it can be opened and evaluated. Okay, maybe there is a fisherman who also contributed and took a photo of a blooming, for this case, Kaunas Reservoir and so on. Yeah, so that's how this interactive map works. And you can check not only your points, but also all the gathered data and so on. Next, what do we have next? Yeah, Zenonas have already mentioned that we have the printed versions of the questionnaires, but I also invite you, and not only you, but to share with your colleagues or whatever, everyone, to fill in the one of these questionnaires. I haven't written it, but it's in Lithuanian, English, and Polish versions. 3 versions, 3 languages. To fill in the questionnaire which is related with the knowledge. What is the knowledge about the algal blooms, their potential harm, and so on? So, okay, we can also try to check how it looks like. Yeah, it's English one. So most of the questions you just click on the, how to say, one of the answers. And after checking all the answers, you just press the submit, or in Lithuanian it's pateikti, and that's it. So it is also not taking a lot of time. It's quite quick to fill in all the questionnaire. Next, what do we have next? Yeah, the final one. We have all of those communication tools that we have created can be accessed. The most convenient way is to come to our website, visit it, and there we can find all of these communication materials. Okay, this is our website, of course, also in 3 languages. And there's, of course, some of the results of the events, the dissemination materials, brochures, leaflets, which can be easily accessible and can be downloaded and distributed online. And about the communication tools that I have just mentioned, these are accessible in every page. So RGS application, you can just click and mark, or you can scan the QR code, access the interactive map. Of course, we have Facebook, YouTube, where are all the videos of some kind of the conferences, our own video that you have just watched at the beginning of this seminar, and ResearchGate, where you can access and find articles that are uploaded to the ResearchGate, and the Facebook as all of the events or recent news and so on. So, okay, I'm not logged in now, so just you can scroll, you can read, you can like, hopefully not dislike. So, That's it from me for the communication tool. So maybe there are some questions.
Thanks, Judas, for brief presentation about communication tools. So, yes, please.
Practice people, how many marks do you have per year?
Per year, okay. I have statistics that when it was started, it is very difficult to, how to say, to involve all the general society or some kind of the whatever people. But now about 83 during the past year, 2021 to 2022, in the season of the blooming season.
I'm just wondering if society even probably knows what the blooming means. I mean, how often do you receive pictures, photo of macrophytes? Maybe they are not the bloomings of algae, but Fertilizers or other vegetation.
Yeah.
Is it often?
From my point of view, we have created this interactive map. We have included some of the brief description. What is the blooming? What type of bloomings can be? But also we receive
photos as examples.
Yeah, as an examples. But of course, we receive, but it's not much. But we receive some of the mistakes where the people just take a photo of the pollen assemblages in the water body. So it happens, but it's not so often. Also, from the Poland, I think the target group of the Maudyklos, because some kind of the institutions, the specialists from the institutions are involved in the marking.
Knows what bloom means. Of course, sometimes we also have some problems to do this. We also have some information when we don't have photos of this. Can you come help?
Yes, so I would like to say also that at universities we have many lectures with students for environmental protection and environmental biology. So they have lectures according to hydrobiology and Watercraft, so they perfectly know how Cyanobacteria bloom and the massive appearance of macroalgae look like. So during the vacation, they also have some projects just to market and also the information to the website. I was talking about society, not about science. Also, but also very beginning for students who, when finished, our project is 5 years. So the student who started the first year will be finishing their study.
You know that it's not so easy to the public. And for example, today we have invited mass media, but no one arrived to the seminar. But maybe we are expecting that in the afternoon part they will, how to say, will come. So to spread the knowledge about this, so it depends. Yeah. Okay. Thanks. So moving further, and now we are coming to the key point of our seminar, because I'm inviting two very important persons. Loreta Dazdiene, who is the owner and director of the joint company Baltic Environment, and also Jokūbas Drazdas, with now for the moment executive director of that Baltic Environment. So, and they will present our new product harvester ISL, large harvester for collecting of cyanobacteria. That we will see in the afternoon in the field. So now I put information about that, and in the afternoon we will have practice for it. Okay?
So hello everybody, welcome you to this very nice and important for the nature conference. My name is Loreta Dragdienė, so I'm the founder of the company Baltic Environment. This is Jokubas Drazdas, he is executive of the company. And I would like to present today, as Zenonas mentioned, the key point of our conference, the prototype Algae Service L for Cyanobacteria collection. First of all, I just want to say that our company, Baltic Environment, has expertise in environmental engineering for already 12 years. We are working in environmental engineering consultations, in research, and also in R&D projects. So we participated with air pollution technologies in R&D projects and also water treatment. So in this project, our company is responsible to create the prototypes. So the first prototype that we created was Algae Service S for the Macroalgae collection. And the second prototype is Algae Service L for Cyanobacteria collections, and I'm going to present it today, and you will see it later in the reality. And also, our company is responsible to use the Macroalgae and Microalgae for biogas production. For that purpose, we have 3 cubic meter biogas reactor when we are treating the algae, and we are producing gas and electricity. So let's start with this presentation. So the main question, what is this Algae Service L? So it is harvesting prototype, and it's state-of-art technology. It means that we invented this technology by our engineers. It was never used in the world before. So it's totally brand new technology. What it is for? To collect cyanobacteria and increase the quality of the water and help fauna. What does it mean, L? It means that it's large harvester because we produce also small harvester. So this harvester collects cyanobacteria. I would like to show you Algae Service L creation timeline. It was the hard work was done in 2 years, but the design of the prototype was since 2016, so it's 4 years project. Our engineering team did a huge job to that this Algae Service L will be finalized. We did more than 400 technical drawings, more than 350 engineering work drawings, hydraulic calculation, hydrostatic stability, different schemes. We prepared building project because when you build the ship, you have to firstly do a building project. Like you, for example, build a house, you have a huge project which is made according to all regulations in the ship industry. Then it should be approved and inspected by Lithuanian Transport Safety Administration. So we also did registration of Algae Service L. So it has all the permits to operate as a water treatment harvester. We did the manufacturing, all the parts of the harvester, and we did a lot of testing and improvements, up to 40 separate part testings, more than 10 testings in Kaunas Reservoir, more than 7 corrections and improvements on separate parts. And we had, of course, more than 5 different designs. So I would like to show you the winner. Actually, this is 2018. So this is Algae Service L creation method. This was the live application and the winner who won the project. So you will see later that it's almost totally different from our final version. It is the second version. You have this version on your prints in the booklet. Yes. So the version, this one was also revised, and this is more like a real version, the third version, because we did a lot of research, engineering, design, calculation, hydrostatics, again, research, remodeling. So this is the fourth version of ISL and the final version of ISL. We also changed catamaran to trimaran, so now it's a trimaran. And this is ISL manufacturing process. You see here the body, the solar panels that are installed, the microfiltration devices, the free pontons, which makes trimaran. Here is some technical information about the harvester. It's a lank, white, it's a huge kind of vehicle. You can say it's more than 8 meters. Mass, it's around 4 tons carrying capacity, because it's a heavy machinery. Because usually ships, they are lighter and they do not have such a high carrying capacity. But because we are collecting Cyanobacteria into the 3rd tank, which is the trimaran tank. We have the collection tanks there, so we have carrying capacity higher, because we can carry at one time more than 1 ton of Cyanobacteria in our ship. And yes, so let's go back a little bit before what happened, before we created that interesting device, even for us. So let's start with the beginning of the project. Cyanobacteria collection technology research. We find out that there is no simple technology to collect cyanobacteria straight from ecosystem in larger scale. What we did as engineers, as research people, because personally I'm also a little bit scientist, PhD I'm doing in my life now. So what we took actions. Firstly, we review the market. So we review and analyze more than 12 different water treatment technologies for algae separation. That is maybe possible somehow to adapt, modify, to collect cyanobacteria from lakes. So we adapted centrifuge, belt press, different pumps, and we even tried, and the result was negative. There is no technology to collect straight from ecosystem, then to carry cyanobacteria that we can use it for high value products, that it should be, quite clean, and so that it can produce the later value. So then we started from the scratch. This is our first scratch. So it's a test model made by project engineers to justify technology. So the technology consists about the scheme is like this. The suction hose is installed in perforated cylinder at the bottom with the filtration mesh on it, and it's lowered into the water. And then there is a pump that attracts the water with the microalgae on the mesh, and then microalgae moves cyanobacteria on the mesh, and it's lifted, and then it's with air nozzles removed from the mesh. So it's this is the basic about technology, but of course it's much more complicated when you're doing such a difficult device. But this is the technology basics. Then we did more research model cell calculations. This is from a few years ago, the first model. You see it works in this scratch model. And we collected with this technology the first liters of our cyanobacteria. Then we started, based on that results, to design the microfiltration devices. This is the first version of filtration system, you see. And with that, we produced devices and we put it on Algae Service S to justify if it works efficiently. And it was, the mesh we used was 93, 103, and 144 microns, because even the mesh depends on the weather, on the species. So we have to be very diverse and have ability to use different meshes that we can change. And the water pumps mesh with microalgae is lifted with electric system, then compressive air blows microalgae to the collection tank. But then we found out that this is it's not enough efficient. That equipment is too heavy. It weighted this one equipment more than 160 kilograms.
So it was quite difficult to operate for one person. Then it's that the angle of 90 degrees is not efficient, and algae removal is not efficient enough. So it worked, but we wanted better. So we started to remodeling devices. So this is the second version of microfiltration system. So we reduced the weight of the filtration equipment. Then we changed the angle of 45 degrees. And of course, we did all the automatization of the system that you can control everything in the screen and not by hand. So this is Algae Service L prototype specifications, which consists the prototype biodiesel engine. We have solar panels, 12 pieces, because we also produce solar panel when we are using prototype. We have parts which makes Algae Service L state-of-art technology. Of course, this technology is patented, and we received the patent from the Lithuanian Patent Bureau. So the technology consists of 4 devices on board by side, working at the same time or separate. They can work each or all together. Then we can change the mesh. We have full control panel for microfiltration devices and the other basic parts that consist on the ship. So let's go to the working principle. So this is for Cyanobacteria collection and equipment used. So we have 4 devices by side that works to collect cyanobacteria and attracts the water with the cyanobacteria. We have then mesh, we have lifting system, we have drainage system, and the tanks in the bottom where we are collecting cyanobacteria. And this is the main parts of the Algae Service L equipment. Here is the permits that we received. So this is certificate of inland watercraft registration. You can, this is in Lithuanian language, but this is the translation of in English language. So we went through all procedures, which is very difficult to get the permits as the creators of the ships. That our company is now like the creator of the ships. We have this registration certificate. We have first technical inspections. We have manual instruction how to use the boat, and a lot of different documents. So here is our product, completed Algae Service L ship, and you're going to see it today. And to be more I think it's always interesting to see videos or in nature, in reality, than pictures. So for that purpose, because the nature is very diverse, you don't know how will be today. We will find much Cyanobacteria or not, because it depends on weather, on sun. So we have also a lot of videos how we are collecting in different weather. So here is Kaunas Lagoon. It's actually negatively surprised us this year, because it was much worse, at least as I see it, the last year. But maybe here is a person from Kaunas Yacht Club. She knows maybe every year she's there how it is. But it was so bad that you see the surface was thick, and the fishes and birds lying on the thick layer. So it's very, very bad, stinky situation. So here is our harvester in use. Probably I will be, I know what is interesting question for you, everybody, about the capacity of harvesting. So I believe that the harvesting capacity is very efficient in my perspective. So in 2 weeks, we collected more than 5,000 liters wet biomass, and per day record was 600 liters. So ISL collects up to 120 liters per hour, depends on concentration, and up to 850 liters per day. Well, it depends how much you work, of course, and if you work with breaks or not. So it's very diverse working environment as well. So I will give now a word for my colleague to present the video.
I would like to add that yesterday, Loretta mentioned that our record is 600 liters per day, but yesterday.
Yes, collection concentration.
Yeah, we can show you the concentration difference because it depends on the weather, on the different factors. Because sometimes there are a lot of cyanobacteria when we have suitable wind, the sun, and when it's very hot, it is easier to collect cyanobacteria.
I can play the video?
Yeah, of course. Okay.
So I would like to also present our creative group that did a massive work. So the managers of the group, me and Jokubas, I would like to thank the lead engineer Balys Rutkauskas and other co-engineers Chotkevičius, Vitkutė, Zagorskis, Aurimas Inčiūra, Karolis Inčiūra, Leščius, Zažeskas, and Lučik, who some part of the team, of course, now are preparing the boat. So I'm really glad that the guys did very good work, and we are quite happy with the results. So we would like to thank you for this. And this is two real pictures that we took. This is the before ISL Kaunas Lagunčio. You see the same boats. And this is the after Cyanobacteria collection. So you see a total difference how we cleaned, well, kind of small area, but still we did this. So, but the word for...
I think we can show some
videos, yeah?
Yeah, videos, how it works. And we will see very soon in Kaunas. I think, yeah.
We would like to also this we did, this is maybe 10 past days result. We invented, I just comment.
Sorry.
So we invented on the small harvester, IS Service S, the cyanobacteria collection on the rotation mesh. So this is different technology than on the Algae Service L. So you can see the conveyor principle collection. So we film it. So this is again new type of invention. Yes.
Reached one ton.
And other video where you can see in details the bell.
Because with this technology we can work in
2 harvests.
Yeah.
I can play, yeah?
Yeah. See. Okay, so the final of our presentation.
So one more video about lunch? Or no?
Yes, so no, okay, you can show as well how it's. You see the water moves because it attracts on the mesh. There is a pump system that attracts the algae on the mesh. Yes, okay. So the final thing is that we are happy that our project is on the news. And last week we had TV3 News visiting the project, and we would like to show you what they showed on Sunday News about our project. So please, Vaidas.
Čia pat Lietuvoje kasmet žydinčios Kauno marios ne tik gražus vaizdas, tai smarvė ir pavojus žmonėms bei gyvūnams, tad mokslininkai į marias siunčia greitąją pagalbą. Pirmą kartą Lietuvoje sukūrė laivą, kuris surenka kenksmingus, vandenį žaliai nudažančius dumblius ir melsvabakterijas.
Žuvutėlis vanduo, papūtus vėjeliui siaubingas dvokas. Taip visą vasarą atrodo Kauno marios, bet gamta pasigrožėti atvykę gyventojai vis dažniau raukia nosį.
Kai kanalizacija kažkokia, nežinau, toks kvapas, kad aš dairiausi, o dabar man tiek plėšia galva, kad iš vis.
Vaizdelis tai nekoks. Gražu, bet iš tikrųjų kvapas nekoks. Tikrai, nosį riečia.
Žodžiu, žalias vanduo ir tiek, reiškia, jis turi kažkokią tai ten mikrobų kažkokių, kad yra kvapas, kad yra smarvė.
Žmonės sako, vanduo žydi. Iš tiesų, taip vandenį nudažo gausybė melsvabakterių, ypač tiršta pakrantėse, kurie suplaka vėjas.
Kvapas nekoks. Nesinorėtų maudytis. Reikia tikėtis, kad išvalys. O mes dabar tik tai vizualiai pasigrožėsim ir labai daug nekvėpuosim.
Išties, mokslininkai jau ne vienerius metus suka galvas, kaip nuo dumblių išvaduoti marias. Vykdydami europinį projektą drauge su verslininkais jie pirmą kartą Lietuvoje sukūrė laivus renkančius dumblius. Štai vienas kaip tik plaukia, kur didžiausia jų sankaupa.
Šitas darbas pats yra labai dinamiškas. Gali net 5-10 minučių bėgyje pasikeisti lokacija melsvabakterių ir mes turime prisitaikyti jas gaudyti. Mes esame pasiekę rezultatą efektyvumo prasme iki 700 litrų per dieną.
Šiuo metu įrenginėjama smulkes melsvabakterės. Bet pritaikyti rinkti ir maurus primenančius dumblius, kurie įsako, kad tikslas ne tik rinkti šią biomasę, bet ją perdirbus ir panaudoti.
Galima biodujoms melsvabakterijas panaudoti. Mūsų grupė išskirinėja fikocianiną, labai vertingą dažą, kuris yra labai stiprus antioksidantas. Iš makrodumblių biomasės mes taip pat projekto metu testuojame biodujas, testuojame žemės ūkiui pritaikymą, nes tai labai yra vertinga kaip trąša.
Kol kas kaip tik demonstracinės laivų versijos, specialistai tikisi, kad po kelių metų jie realiai imsis valymo darbų. Nors pripažįsta, kad surinkti viso šio milžiniško dumblių kiekio Kauno mariose neįmanoma. Tokie užmojai prilygtų Sizifo darbui.
Viską išvalyti yra aišku, kad nerealu. Tai yra, kaip prasme, utopija, bet nuo kažko pradėti reikia. Ir jeigu bent 1% mes galime išvalyti ir pagerinti aplinkosakinę situaciją, aš manau, kad tai yra labai puiku.
Reiktų ir kompleksinių priemonių, ypač mažinti į Kauno marias sutekančių upių ir upelių taršą. Mat būtent azoto ir fosforo dideli kiekiai skatina dumblių ir melsvabakterių augimą, o šie laivai pagelbėtų ten, kur koncentracija didžiausia.
Mūsų laivas ir yra ta reanimacija. Tai yra priemonė, kad padėti vandens telkiniui tuo pačiu baisiausiu, pačiu sudėtingiausiu momentu. Taip lokaliai, dideliuose vandens telkiniuose laivas gali išrinkti tą biomasę.
Jei makrodumbliai primenantys greičių siūlų gniutulus tik bjauriai atrodo, tai mažytės melsvabakterijas dar ir itin kenksmingos.
Tie toksinai, kurie yra melsvabakterėse Kauno mariose, tai yra pavojingi, tai yra hepatotoksinai vadinami, jie akumuliuojasi organizme, kaupiasi kepenyse ir pažeidžia virškinimo sistemą.
O pavojingiausia, kai rudens pradžioje melsvabakterės suyra, žalia spalva išnyksta, bet vandenį pasklinda kenksmingi toksinai. Reikia saugoti ir save, ir augintinius.
Galbūt žmogus ir dar suvokia pats, kad reikia neiti po žydėjimo, tikriausiai daug kas net nesimaudo tokiuose vandens telkiniuose. Bet augintiniai dažnai pribėga ir tiesiog laka. Yra buvę atvejų Lietuvoje, kad yra netgi ir žuvę du šunys.
Specialistai sako, kad ir žuvies pagautos tokiame vandenyje derėtų vengti, mat joje taip pat kaupiasi toksinai.
So, thanks so much for Loretta and your feedback. Questions, but at first I would like to ask maybe somebody from outside would like to ask.
Yes, we have a question from Ugne. The question is from biorefinery perspective. Do you perform biorefinery yourself? If yes, can you use same processing approaches for different cyanobacteria species? How do you monetize your activities?
So,
I think it.
So, about the monetization of the activities, so we have now we do not get any income of the project because it's a prototype. So we are using the finance mechanism, the LIFE project finance us to create these prototypes, but we will have shortly in 1 year time our business model, how we can actually transfer to the real market these prototypes. And also we are calculating the maintenance costs versus prototype creation costs. The other group is doing that, so we will have this result in our final reports.
Because because we have a lot of questions. Some people ask to help them to clean, for example, in Kaunas Reservoir, guys from restaurant are coming. Maybe you can clean our water because the clients cannot eat in the next to by the water because of the bad smell and so on. But at the moment, as Loretta said, that we cannot get money for our services. We just doing in the project.
Some more questions from the audience?
I don't see any raised hands.
Yes, one in the call.
Ella, please.
Yeah. I think so. What will be the final price for harvest?
So we are still calculating, but obvious that we will have savings more than 30% that we had in the budget. So even in this difficult times, we did in very economical, effective way harvesters, and even it was difficult with the COVID and with the material supply, but yes, we will calculate.
But I think about the price, if somebody would like to buy it, and because some companies ask us, so what is the price? I would like to buy it.
I think it's difficult because now we are investing in the technology and we are improving it every day, as we were showing you. So it depends, the business model. Sometimes you invested, for example, 1 million, and you are selling your product for €1, for example. Yes, so it's very different. But at this time, it's very hard to say.
I understood that Ella's team would like to buy it from you.
When we will have the
maybe negotiations in the afternoon.
Yeah, because when we will have the final version of the prototype, then it will be easier to calculate how it will cost. Because we have a lot of challenges because of the inflation, of supply chain problems, because of staff, because changed a lot of people who was starting working with us, doing this job, quite difficult job, because you need to live this. You need to do it every day and on the weekends. Yeah. So at the moment, it's very hard to see. We will see. I think in 1 year or 2 years, we will have the final version and we will have the final price to go to the market.
Final contract.
Okay.
Business to business.
One more. So, do you think also about renting it?
Not just sell, but also renting.
It could be possible to provide like a service for some organization. For example, for like a Kaunas Club, yeah, we can provide services because our guys already know how to work with those devices, sometimes it's very hard to know the location where is the cyanobacteria, and those guys already know where to look for the cyanobacteria, where to get the best result.
Yeah, Jokubas, I guess the priority for project partners. Later we will see.
You mentioned about collection capacity 20 liters per hour. My question is, what is the water content of climate?
I can answer. So basically, we are calculating the wet biomass that we are extracted with the ship, but our colleagues recalculating dry matter according to their technology. So maybe Judita can, because they are doing research on the concentration.
Have done the research because this amount of biomass in each time we collect is different. So we know that a very dense biomass is from 3% to 6% of dry biomass. Then we recalculate each time we measure and recalculate into pure wet biomass. So this way. So that
No more questions from the auditorium. Sorry, you will have possibility in the afternoon on the remote audience.
Yeah, one more question. Do you think your harvesting ship will work in marine waters? Maris Tulgis. Question is from Maris Tulgis.
So this ship, this particular ship is for the, even in registration certificate, you can see it's inland water. So for the marine, for example, Baltic Sea, it's not possible to operate with the ship, but we had colleagues from Sweden that are working with Baltic Sea algae removal. So they saw our results and they were interested maybe to apply this kind of technologies or to modify the technology and apply for the salt water in the marines. So we are talking about the possibilities. This particular ship not, but the technology itself, which is on the ship, probably could be.
Only the first one.
Also, there is a question from Maya. Maya is raising hand, so.
Okay, hello to everybody. I'm just a little bit ahead because I'm afraid that there is interruption in the connection. Wanted not to ask question, but to thank from the name of whole Bulgarian group to Judita and to Zenonas for invitation for this seminar, and to say that it was extremely interesting. Your work is very, very important. I think we all experience, especially this year, the results from global changes and blooms and floods and so on. And this work is extremely important. We got a lot of experience, and this seminar was very, very important for us. So thank you very much for the invitation and for possibility to be involved and to listen to all this and to see these very interesting machines. And I think they have a big future. Good luck in your work.
Thanks, Maya.
Thank you very much, Maya.
Thank you.
Also, one more raised hand, Maris Tulgis.
Yes, hello. I'm trying to switch on my camera. Do you hear me?
Yes, we can hear you.
Okay, maybe you can see me as well. Yes. Yeah. Indeed, I'm from DG Mare, and then you might know that I'm also driving forward the EU Algae initiative that is currently in the inter-service consultation, and just to really congratulate you with already the current results of the project, because it's not so often that you have such specific deliverables at the end of the project that could be really already moved to the market. And the question of Ugne as relates the monetization of the activities, it's really really important. But the most important is that the European Green Deal and the same as algae initiative, it's very important to really turn the environmental challenges and problems into the opportunities. And this is exactly the case where you are really finding out how to turn the environmental problems like algae blooms into the business opportunities. And it's not just that you can do the services, of course, and monetize it from the services, but making the products or looking a bit further, it's really useful to get this monetization in that way. My question about of course, the EU algae initiative is mostly focusing on the EU marine waters. But I think that the prototype that you have created to collect these cyanobacteria in inland waters, it certainly could be replicated further to the marine waters. And you could also maybe look beyond the Lithuanian borders to see where there are other areas where there are algae blooms, really to expand your collaboration with other countries, because we can certainly assume that with the climate change and with the rising water temperatures, you will have more algae blooms. And that's why I think that this project result that you have created is really timely and really necessary. So congratulations again, and it's really good, and we would love to be in touch and also see all the presentations and the final results. Thank you.
Thanks a lot.
Thank you. Thank you very much.
Thank you very much.
Thanks once more, Loretta, and your Ubas and your team.
Thank you very much.
Yeah. A spare of space. And they will get in that a lot of questions. We are late so strong today, but now it's very proper person is coming. Dr. Daiva Simenina, Director of Center of Environmental Policy, representing joint stock company Spila now as external expert. Spila is our partner as well, and Vytautas Rimkus, could you show yourself? He is director of that joint stock company, and together with Daiva, they are doing evaluating in money sense. So they started to talk how much. So now we will talk a little bit about money. Yes, Daiva, please.
Yeah, hello, nice to see you all here. And the last questions for the previous presentation showed how money is important. And I would say that, yeah, it was very interesting, but is it good for society, such a thing? In order to do that, we need to compare costs and benefits which we get from all that machinery which we get from this project. Each life and not only life project requires to make socio-economic impact. And this is very important, because if we are producing something which is very, very costly, but benefits which we get are not so big, so then it's not clear whether we need to do that. So as I said, I am involved here in this project to make a socioeconomic analysis after, basically at the end of the project, because as you heard, still not all costs are clear. I will just tell in a second, we are trying to to evaluate, to assess benefits. So I will tell just what we are doing right now. I cannot say you what is the benefit cost ratio. It will be in the final conference, as you said, when we will know all costs and all benefits which this project and in general cleaning of Kaunas and also other water bodies bring to society. So yeah, why do we ask how much water is worth? So I said, first of all, it is required by the project. It helps to compare cost, which is really in money, and benefits, which are not so clearly in money, but we are trying to make those benefits in money. Then it will give better, it will provide information and knowledge for better decision making. Yeah, and as I said, we will be able to compare costs and benefits if we know how much clean water, in this case, in Kaunas, in Kaunas Reservoir is worth. So just, I have very little time, so I cannot really say many things, just a very, very small aspect. So water resources, water bodies provide to us many, many good things. So-called ecosystem services, you all know now it's very widely used. So some ecosystem services which results or products of ecosystem services, they can be put in the market. So then it's clear if you get fish and if you buy and if you sell that on the market, you can most probably have that in money. But some ecosystem services cannot participate in the market. So the only way to assess, to evaluate this ecosystem service or this, let's say, good which nature, in this case, water resources provide to us is so-called willingness to pay, assessment of willingness to pay for better water quality valuation. So at the moment, we're working on this in this project. We are working on also other things, but as I said, I'm just concentrating on this. So we are preparing, or basically we have prepared already, willingness to pay study, willingness to pay questionnaire, which will be distributed to all people in Lithuania. I mean, not all, representative sample of people in Lithuania, where we will basically ask them how much they would be willing to pay, stressing that this is not real. We are not going to make any tax, anything, but it's just a way of questioning how much they will be willing to pay for better quality, for better water in Kaunas Marios, in Koronian, Koronian was before, but in Kaunas Reservoir. And you see what is the current status, it's written, and what will be the good status. So this will be one of pictures which maybe some of you will receive that questionnaire by chance. So it will be one of pictures in that quite a big survey, quite a big questionnaire. And we will be, of course, asking people what is their perception, what maybe they have visited Kaunas Reservoir before, maybe they are going there very frequently, what they are doing there, and so on, and what they would like the Kaunas Reservoir would look like in the future, in, let's say, 2040. And we will ask them, as I said, how much they would be willing to pay. And if they are not willing to pay, why? And if they are willing to pay, also why, and how certain they are about that. And as in all surveys, we will have socioeconomic profile and some other reactions from respondents to ask whether they are environmentally friendly in general or not. So this survey will, after statistical analysis of the data which we will receive, we will be able to say how much
on average, one Lithuanian is going to pay for improving Kaunas Reservoir water. It means that our Kaunas Reservoir water costs so much. So we will be able to multiply and to make various other things, and we will get the national figure. I would just like to say that we had quite some years ago some willingness to pay study surveys, but they were, as you see, quite some years ago. So the average, taking into consideration now inflation and all those things, on average, one person is willing to pay, or it values water around 7-10 euros per year. So he says, or she says, that I'm going to give to pay 10 euros that certain water body is clean from eutrophication, in this case in Lithuania. So let's see what our survey for Kaunas Reservoir what kind of results it will provide, and what kind of after statistical analysis, what kind of results we will be able to. Everybody is looking for lunch for the next before next.
So Daiva, thanks a lot, and we can make a test now and to ask people how they would like to pay, for example, during the next years for Marios cleaning of Kaunas Reservoir. €1, €2, €3 per year. How much?
It's for 10 euros.
It's a possibility, yeah. So if you will get a question, or if I was questioned, so don't hesitate, please fulfill that post. No one knows who will be sample audience, yes? Yeah, okay, thanks a lot. That was Now, Beata Meškieš, professor from Adam Mickiewicz University in Poznan, is coming for our last presentation before the
Work for 2 seconds.
After that, we have lunch time. And later, I will explain all the logistics of the last part of this presentation. Okay?
Yes. And this one. Yes.
So, Beata, please.
I represent the University team, which is composed by biologists and chemists. Let's say what said in previous presentations. So I put the information which are connected mostly with macroalgae and this work which we are doing and the efforts that we received. So eutrophication process, which was mentioned earlier, it's connected with some changes about physical chemical parameters in water, mostly with the increase of nutrients. It means nitrogen and phosphate concentration. And we, of course, can see according to the high temperature and the changes in the climatic changes. So you can see the blooms of cyanobacteria, but also according to the eutrophication process and this increase of nutrients, we can see the rapid growth of biomass of macroalgae, which also are visible very easy on the surface of that lake. So such mass appearance of macroalgae can be noted not only in ponds, rivers, but also lakes, deep lakes and shallow lakes. So in deep lakes, mostly in shallow bays, where they concentrated in the littoral zone, but in shallow lakes, as you have here the examples, this appearance can cover about even 80-90% of the surface of the lake. Yeah, so it is like a huge amount of the biomass. So when we look for characteristics of the mud structure, so just for collecting, for harvesting, and also the important information, how the mud is built. So it means that we can recognize like the three main kinds of mud structure. It means that it can be free-floating mud in the surface, what will be very easy just to collect. The next
parts, it is like a mud structure connected with attached to the bottom, macroalgae. So we can, even when we have in such water ecosystems, such macroalgae, we have to wipe if they are starting to be in the surface, yeah, just to better collect. And the mixed mud, like overgrowing the entire water column. So it means that even when we have submerged plants, the macroalgae use as a pillar just to attach and the build and overgrow all water column. When the depth of the lake, like shallow lake, will be 2 meters, we have from the bottom to the surface such wide parts of the macroalgae plants. So we mostly work and collected macroalgae from lake, which is very shallow, located in Wielkopolska region in the west part of Poland. So as you can see, it is shallow lake, average depth, it's lower like 1 meter. The deepest part, it is only maximum depth 1 meter 70 centimeters. And water visibility, it's mostly 40 centimeters. pH is very high, figure like higher like 8. And it, of course, it is like eutrophic lake. And characteristic for this lake, there are permanent each year appearance of the macroalgae mass. So when we're looking for the mud, we can see that the mud are like a 2 type flowing on the surface. And also, even when we see here some water, it is not the water underwater, still they are attached and using submerged plants like a pillar, still we have macroalgae. Just going to the more important information, which also is needed, because macroalgae, there is not one species. Filamentous algae, there are many species. So we should know also that when appears such mass in the water, it can be built by different species, and it has the consequences when the biomass will be higher and when can be collected. So going to some species which are the most popular, build the biomass very fast in waters in Poland and Lithuania. So you can see that the most often is Cladophora glomerata, which prefers eutrophic waters. And as you can see, for nitrogen and for orthophosphate and nitrogen, they really prefers high concentration. But also we have some other species for the general Cladophora, like Fracta regularis, especially regularis that can be found in rivers, prefer waters with low nitrogen and phosphate. So such a big appearance of green algae can appear in very high eutrophic water, but also in water which have lower nutrients in the water. Very important is also temperature. According to the season, vegetation season, when we want to harvest such species. So as you can see, we can find and recognize by this blue color. There are some species like Tribonema ulotrix, which we call species which like cold loving taxa. So it means they are early spring taxa with occurrence of in temperature lower in 20 degrees. So they can start very early their appearance. And of course, we have the most popular Cladophora glomerata. As you see, she starts their appearance development very early in the spring, and she prefers lower temperatures. So we call it like pioneering species. So it's also the reason why this species can be distributed in many water ecosystems, water above. But as you can see also, we have the red one as an example, Oidogonium capillare, not only one, you see there are others. which have optimum of occurrence higher than 20 degrees. So it means they are thermophilic species, macroalgae. It is very important according to the climatic changes. Yeah, because when we will have very hot weathers and very hot summers, so mostly can be shifted from Cladophora glomerata to other species which are thermophilic species. We will not see like the normal people will say, okay, we have macroalgae, we have still macroalgae, but we have different species which can have different quality as a material which you would like to use as a biomass. And also connected with some anthropogenic changes, it means that chloridium, chloride concentration changes for some species also will be important for Cladophora glomerata. It is just in the middle, like 48 milligrams chlorides per 1 liter. Very important also for such changes in environment. It means like increased temperature during the summer. So it is like the environmental stress. And in macroalgae, the same like in the plant cells, you can see increase in proline production. So it is very important for the changes in the structure of protein and chlorophyll synthesis. Yeah, so also can change the quality of biomass later. And just looking more closely for environmental stress connected with some other species like Cyanobacteria blooms, rapid proline growth, so are characteristic for taxa sensitive to stress. And there are some Cladophora, for example, fracta. And we have such taxa which, according to the stress, have slow proline growth. And they are taxa resistant to stress. And Cladophora glomerata is like the very resistant for any factors of stress. But is also very important information for us. So just going to more synthesize what previous speech talk, it is why macroalgae are important in our project. As you see, according to the chemical analysis, it is visible that in each cells, in the biomass of macroalgae, we have a lot of compounds such as fatty acids, amino acids, microelements, and such biomass can be great of economic importance. So can be used for economic purposes, for the development of new ecological solutions. Yes. So our project and also our task, which we did and we still doing in this project, go to two main directions. The first, it is information about practical use of biomass and to look for natural fertilizer, feed ingredients, in some way, IBCDs, biofuels, absorbent in wastewater treatment, plant biostimulator. And the second part, which is also very important, according to harvesting the biomass, it is reduction numbers of appearance of macroalgae in the waters, especially for such lakes which are recreational used, yeah, and according to the tasks and our aims, we want to improve the water quality, biodiversity increase, and improving the recreation attractiveness of the bathing area. So our work, collecting biomass, drying biomass, grinding biomass, and have that biomass for future analysis in the laboratory. Just going to these two directions. The first, agriculture and use macroalgae biomass as fertilizers, natural fertilizers. As you can see, for plants, we have some necessary elements for growth and development of plants, like macronutrients, micronutrients, and also elements beneficial for the growth and development of plants, which are needed in small amounts, but still are needed. So just going to compare the biomass of macroalgae to natural fertilizers. You have the concentration of some chemical components for manure and our algae-like macroscopic macroalgae. So you can see that water, organic substances, nitrogen, phosphate, magnesium, potassium, sodium, they are comparable. But differences with higher concentration compared to normal manure, it is concentration of calcium and silicon. It is, of course, connected with such parts that on the surface of macroalgae we can find also attached diatoms and also crystals of calcium. So it is a concentration higher than other fertilizers in calcium and silicon. When we look just very shortly, we can use the biomass as a wet biomass and as a dry biomass. So using as the wet biomass, so the pluses are increase in moisture content of dry manure, immediate availability of all bioactive substances for plants, and also when we will have longer storage, just this biomass, and use later. Important is homogeneity of this material because wet biomass is wet, so it will be not drying manure, and humidity penetration of all layers. But also important is that we can use dry biomass as extracts. And the pluses, it is also easy to store for longer time and can be used in doses during the spring. So it is another way for use such programs. And so key benefits of macroalgae as a biofertilizers, as you can see, I found and put the 5 most important. So ultra-fast nutrition effect, quick and easy absorption of macronutrients. The next, very high concentration of nutrients inside the biomass of macroalgae, up to 55% more nutrients compared to standard pellets than you would like to use. Then another, high performance, biodegradability, and excellent solubility and miscibility with agrochemicals. It is also very important to have such effect. And the another parts which we worked with macroalgae, it is algae-enhanced cosmetics. So just very quickly, we have the biomass, we have isolation, and we have prepared extract. And in extract, we have active substances like polyphenols, fatty acids, vitamins, chlorophyll as pigments, and we have also some spec material, which can be either like eco-scrap. It means lignocellulose, diatoms, this calcium carbonate crystals. So looking for these active substances, we found that we have dominate saturated fatty acids, especially palmitic acid, and also some others like myristic, stearic, and aldehyde. So such fatty acids, saturated fatty acids, are very important for health of people. So they are very good information that we have. And also, as you can see here in the slide, there are different methods which we can receive them, and also we optimize such method to have the high content as is possible. So in such biomass, we can find also chlorophyll A, chlorophyll B, carotenoids, and as you see, these two methods are the most effective for obtaining such pigments. And also phenolic compounds, which according to the analysis, we found mostly such quinic acid, gallic acid, fumaric acid, also which are very important and the same which can be found in normal plants. Sulfated polysaccharides, contain a sulfate group, come from cell wall, constitute a building material of algae, dry matter to even 29%. So ingredients, there is glucose, cellulose, rhamnose, mannose, arabinose, galactose, uronic acid. So all kinds that are very important during preparing cosmetics. And returning for our basic of cosmetic preparation. So we have two phases, water phase and oil phase. So as you see in each phase, there are some good compounds which we would like to have together. And it is needed emulsifier, which are noted on the red color. Okay. After mix it, we can receive the stabilized emulsion. And the next, it is work with cosmetic safety report prepared. And according to have such report, we need our sample to test it in many ways. So to conservation stability and to emulsion stability. For conservation stability, it means that cosmetics should be without bacteria and fungi, and also very popular is a challenge test like mass eliminate, control, deliberate contamination. Emulsion stability, as you can see, they are testing low temperature and high temperature, and also measurement of droplet size and agglomeration. And such emulsion must survive without breaking and important physicochemical changes. And as I saw, some parts of cosmetics are during the break outside, and some people also tested. This is the effect of our work, so you could check this. So going to the conclusions. Gladovora glomerata, as the example of macroalgae, was found as a source of various bioactive compounds, fatty acids, carotenoids, phenolic compounds, sulfated polysaccharides, and extracts from such algae possess antioxidant properties. It is very important. And added to cosmetics, increased skin hydration and elasticity. So biomass can be used as a new cosmetic raw material. And returning from the first slides, I can say, according to our data, that practical use of macroalgal biomass, natural fertilizers, yes. Feed ingredients, yes. Algicides, yes. Biofuels, which Loretta's team for sure proved this, I hope, yes. And absorbent in wastewater treatment, yes. Plant biostimulator, yes. Going to effects, which you would like to receive after taking out the macroalgae biomass from the water. Improvement of water quality, yes. Even Jurate showed as some example in her presentation. Biodiversity increase, yes. It is just, I show in Weknejskie Lake, after even one harvesting short time, we had improvement in the biodiversity of phytoplankton species in 20%. So it is a really good result. Improving the recreation attractiveness of the basin area, for sure. When we don't have macroalgae, when we will not have in such areas Cyanobacteria blooms, people can use safety such water passing area. Thank you for your attention, and I hope that I was in my time.
Yes, of course. Yeah. So thank that you reminded us that one big part of our project is also macroalgae, not only cyanobacteria. Of course, we did focus today is to cyanobacteria, but as well, you see that very nice products. I know that you have expected. You came for the on purpose to get a bottle of cosmetics. Sorry about that. But I propose you to sit together with that during the lunch.
Thank you with my colleagues.
Yeah, and I would like to remind that team members of that, Radek and Bogusha, they are representing the Faculty of Chemistry. Yeah?
Yes.
And this very nice cooperation of Faculty of Biology and Faculty of Chemistry, you saw a lot of different formulas, chemicals. So it means that we would have good results in cooperating how to say, specialties and fields. Okay, so maybe some questions from outside?
No questions from
No
outside
comments,
or
no.
online?
No. Okay.
Maybe,
Okay. there is
can
a
you hear me?
Yes.
This is Sugna, and I have a question. Maybe this is more about opinion of yours. There are so many applications, potential applications, but what do you think, why in Lithuania we don't have that much, let's say, startups or the companies who are working on the algae?
I think that it is not a problem only for Lithuania. It is also the problem for Poland, because most people were interested in marine algae. We work on the freshwater algae. So it is very important for some companies that also freshwater biomass can be used and has also a very good valuable compounds in the soils, which can be used just for cosmetics and the fertilizers. People were interested mostly in marine macroalgae. So as you know, it is we have very short seashore. So for some algae, it was like macroalgae to use in the company. It was to take outside, so they were cost. When we know for this moment that we can use freshwater biomass, it is just changes the mind. So I'm sure that in Lithuania and in Poland, very fast some companies appear.
Okay, thank you.
You're welcome.
More questions? No, no, sorry. Yes, please.
Did you present your information to the business sector? Maybe they would like to start a business from this problem. We try to make the simulation to many groups, as many as possible. So we have some talks with some people, but of course, at first we would like to finish our project, have stabilize data, just to distribute it around.
And one more moment that during the next year, the end of the summer, I guess, something like that, we will organize special seminar for businessmen. So we are planning to have the seminar in Vilnius, and we will invite business people to gather together. So we will analyze all these possibilities.
Yeah, that's for such important parts like cosmetics, they are important validation, reputation of many analyzers to be sure that they are healthy and they can be distributed. Or later you will see. So that would be possible, why not?
So like this, no more?
No more questions?
Yeah, no. So thanks, Beth, once more, and for your teams, for your information. Now, so I would like to thank you all. Maybe someone would like to, how to say, because we have time for the discussion, but we missed this time because we are out of time. We are late a little bit. So maybe we will postpone, if someone from remote auditorium will have some ideas or some questions or some remarks or whatever, so please write maybe
Directly in questions and answers section.
or send by email or whatever. So please contact us and invite us. Maybe you can explain what will be in the afternoon, because in the afternoon session we will start at 3:30.
At 3